Very good morning to one and all. I hope all are fine. So, let's start with today's topic, that is hypermetropia. Basically, we are dealing with defects of vision. You know that, and its correction. So, till now we have discussed myopia only. Now, defects of vision is being categorized into four categories. You know that. One is myopia, hypermetropia, presbyopia, or cataract. So, myopia is done. So, myopia is short sightedness, or we can say that myopia, if anyone is having myopia, then he or she is not able to see the things that is very far. He or she can see things that is near but not able to see things that is far. So correction में हम क्या करते हैं? We will use a concave lens. As you know that concave lens is a diverging lens. So any object in front of a concave lens, it will make a virtual image in front of a lens. So that image for the eye lens behaves as the object, and then the image is formed on the retina. Otherwise, if you are myopic, then the image is formed in front of the retina. Yes or no? So what now? Let's start with the hypermetropia. But before starting with hypermetropia, why defects of vision are there? I forgot to discuss this in last video. as as you grow up, or so many biological changes in human body, so due to these changes, ciliary muscles become inactive. So with the time, ciliary muscles become inactive, or they are not able to do their work properly. So what is the work of ciliary muscles? Expand or contract. So what happen, as ciliary muscles do not expand or contract according to the need of a person. So if ciliary muscles are not able to contract or expand, then the eye cannot accommodate for clear vision of objects. ठीक है, ये हमने पढ़ा accommodation of an eye, power of accommodation. So an eye cannot accommodate clear vision of objects for even near objects or for the far off point or far off objects. दोनों के लिए भी नहीं कर पाती है. That is presbyopia. So in other words, we can say that eye is unable to see the objects clearly, और इवन ये भी बोल सकते हैं आई इज नॉट एबल टू फॉर्म द शार्प इमेज ऑफ द ऑब्जेक्ट ऑन द रेटिना. दैट इज फॉर बोथ द केसेस, नियर and the far, or even for with the age, these two defects occur simultaneously. So that is called a defective eye. So one is myopic and the other one is hypermetropia. Now hypermetropia, now let's start with the topic hypermetropia. What is hypermetropia? Hypermetropia is also known as long sightedness or far sightedness. Long sightedness or far sightedness. Clear? So what will be the definition? A human eye which, now hypermetropia. So as the name itself is suggesting, long sightedness or far sightedness, it means a human eye which can see of far objects clearly but are not able to see nearby objects. इसका मतलब है अगर कोई ऑब्जेक्ट आपने बहुत दूर रखा है, he or she can see, but if the object is very close to eye, then he or she is not able to see. इसका मतलब है कि लीस्ट डिस्टेंस ऑफ विजन 25 सेंटीमीटर जो है उसमें प्रॉब्लम आ रही है, एंड uh, far distance of vision is correct. So a correction of long sightedness or hypermetropia. Let me draw the diagrams, and these diagrams are very important. You have to draw also. So what we are, according to definition, as you can see, I have pencil also. Let me draw from pencil. This is bulging part out. So as you know that this is cornea. So what is happening in hypermetropia? A human eye which can see far off objects clearly but cannot see the nearby objects. Nearby object, it means if object is posed at, this is O, this is object, and this object O जो है, दिस इज लीस्ट डिस्टेंस ऑफ विजन, दैट इज 25 सेंटीमीटर. सो अगर आपके पास ऐसी सिचुएशन है, ऑब्जेक्ट इज वेरी नियर, दैट इज एट अ लीस्ट डिस्टेंस ऑफ विजन. सो यहाँ पे क्या बना, कन्वेक्स लेंस, सॉरी ह्यूमन आई में कौन सा लेंस होता है, कन्वेक्स लेंस. सो लाइट रेज फ्रॉम will go like this, and then what is going to happen, they will not converge on the retina, they will converge behind the retina. So this is the situation as light rays, this, so this is the image that is behind the retina, and this distance is least distance of vision, 25 centimeter. So this is the near point of normal eye. You know that near point for normal eye. So this is near point of normal eye, as when a person is suffering from hypermetropia, he or she can see far off objects, but least distance of vision, that is 25 centimeter, he or she is not able to see that object clearly. So for such cases, image is formed behind the retina. So this is a diagram, that is eye suffering from hypermetropia. This is the, according to the definition, what is this? This definition I have been convert into diagram. Eye suffering from hypermetropia. Hypermetropia or long sightedness. Now how we can correct this problem? Let's think upon this. Now what is there in definition? A person suffering from hypermetropia can see far off objects clearly, यानी कि दूर की चीज़ें ढंग से नज़र आती है. तो what we have to do, we have to bring this near point to some more distance. We have to increase this near point. So if we will going to do that, then क्या सिचुएशन होगी? सपोज दिस इज पेंसिल, दिस इज आई, sorry, this is not properly being made. Let I have an eraser, sorry. Bulging out part, ठीक है, this is bulging out by cornea. So now what is there? Here it is convex lens. So if we want to make object to form its image on the retina, so what we have to do? We have to increase the near point. So what we have to do, as we can see, a person in hypermetropic problem can see objects that is far. So हमने उस near point को हमने ये कर दिया यहाँ तक. So जब ऐसी situation आई, so when we have done something like this, तो object ये है lens, so इमेज बन गई रेटिना पे. ठीक है. This is image eye. So this is near point of defective eye. This is the actual near point. When this actual near point is there, so image is formed behind the retina. So to make image formed on the retina, we have to increase the near point of this problem. So this is the, we have to make this near point, so image is formed on the retina. Now how we can do this? Which type of lens we have to use? Yes, we have to use the convex lens. Why convex lens? Yes, why convex lens? When we use convex lens, now let me draw first, then I think you will get an idea. This is cornea part. This is so this is the actual object is here, I think. Yes, it is here. O is here. Now we have used a convex lens. This is object. So going to bend little bit. And then image is going to formed on the retina. This is eye. Now what happened? So when you have used a convex lens, that is very last case. You can see that is a last case. When object is very near to the lens. So what happens? इस ऑब्जेक्ट की उसी के सामने क्या बन जाती है? वर्चुअल इमेज. सो दिस इज इट्स वर्चुअल इमेज O dash. Now this is virtual image O dash, and this image is of this lens. Or then again same. Now I am going to make you understand one more time. This is the correction of long sightedness. Long sightedness, and दिस डिस्टेंस इज d, वहाँ पे भी हमने d डिस्टेंस लिया था हाइपरमेट्रोपिक आएगा। Image distance there is also d. Now अब ध्यान से देखेंगे what we have done. So we have to do this because we have to increase the near point. So how we can increase that near point? We can use a convex lens. Okay, that convex lens ऑब्जेक्ट के जब बहुत ज़्यादा नज़दीक है, इट इज़ गोइंग टू मेक वर्चुअल इमेज दैट इज़ फार, वेरी फार फ्रॉम द लेंस. So that virtual image for the eye lens will act as an object and the image is formed on the retina. अगर आप मायोपिया का देखेंगे, मायोपिया में क्या था? You can see far off objects carefully. You can see in myopia, you can see near objects carefully and far off objects are having some problem. You are not able to see far off objects. So what you have done? So as you can see, when healthy human eye is this. So when you have myopic problem, that when the rays is coming from infinity, then that will converge in front of the retina. This is myopic eye. So what we have to do? We have to bring this far point, जो दूर का हमें नज़र नहीं आ रहा है, उस far point को हमने क्या लाना है? नज़दीक लाना है. ठीक है, तो अब यहाँ पे आपने क्या किया? You have put a concave lens. ठीक है, अब ऑब्जेक्ट इज बेसिकली एट इन्फिनिटी, तो आपने क्या लगाया? कनकेव लेंस लगाया. कनकेव लेंस क्या करता है? वर्चुअल इमेज बनाता है. ठीक है, इन फ्रंट ऑफ द लेंस. सो ये इमेज जो बनी, ठीक है, अब दूर का नज़र नहीं आ रहा है. ठीक है, इसमें दूर का नज़र नहीं आता है, तो उस दूर के ऑब्जेक्ट की कनकेव लेंस ने क्या बना दी? इमेज बना दी नज़दीक. ठीक है, ठीक है, नज़दीक का यहाँ पे अच्छे से नज़र आ रहा है. ठीक है, तो अब ये जो इमेज है दैट फॉर द आई लेंस इट विल एक्ट एज एन ऑब्जेक्ट एंड फॉर्म द इमेज. सो दिस इज डी. सो सिमिलरली हेयर, यहाँ पे आपके पास यू आर एबल टू सी फार ऑफ ऑब्जेक्ट्स, यू कांट सी नियर ऑब्जेक्ट्स. नियर पॉइंट इज बीइंग हैविंग सम प्रॉब्लम, सो दैट इमेज इज फॉर्म बिहाइंड द रेटिना. सो इसके लिए आपको ये करना होगा, यू हैव टू इंक्रीज द नियर पॉइंट. उसके लिए आपने क्या किया? कन्वेक्स लेंस लगाया. अब कन्वेक्स लेंस में ऑब्जेक्ट ये है. ठीक है, कन्वेक्स लेंस में ऑब्जेक्ट ये है. व्हेन ऑब्जेक्ट इज वेरी नियर टू लेंस, कन्वेक्स लेंस, देन इट विल फॉर्म अ वर्चुअल इमेज. तो वर्चुअल इमेज कहाँ पे बनी? लेंस के सामने ही बनी, ये बनी. ठीक है, तो व्हेन इट इज गोइंग टू हैपन फॉर द आई लेंस, इट विल बिहेव एज अ object and forms the image on the retina. So I hope now you get an idea. Now what are the causes? So question can be asked for 1 marks. How you can remove the defect hypermetropia? You have to use convex lens. And how you can remove myopia? You have to use concave lens. Clear? So you, for hypermetropia, you have to use a suitable lens, that is convex lens of suitable focal length. So causes of hypermetropia. अब क्या कॉजेस है? उसमें क्या कॉजेस थे? मायोपिया में क्या कॉजेस थे? मायोपिया में क्या कॉजेस थे आपको पता है? आपके पास मायोपिया में क्या हो गया था? मायोपिया में आपके पास एलोंगेशन ऑफ द आई बॉल एंड एक्सेसिव कर्वेचर ऑफ द आई लेंस. यस और नो? अब यहाँ पे क्या कॉजेस है आपके पास, यहाँ पे कॉज द साइज ऑफ द आई बॉल बिकम्स टू स्मॉल। यहाँ पे हाइपरमेट्रोपिया में तो यहाँ पे आई बॉल का साइज बहुत छोटा हो गया है, तो इमेज कहाँ पे जा रही है, बिहाइंड जा रही है। द वहाँ पे साइज बहुत बड़ा हो गया था, तो वहाँ पे साइज बड़ा हो गया था, तो इमेज कहाँ पे बन रही थी, इनसाइड द आई बॉल। तो यहाँ पे क्या है, पहला द साइज ऑफ द आई बॉल बिकम्स टू स्मॉल। कॉज क्या है इसका, द साइज ऑफ द आई बॉल, the size of the eyeball becomes too small, and number 2, साथ ही साथ नंबर 2 क्या है यहाँ पे हाइपरमेट्रोपी, द इंक्रीज इन द फोकल लेंथ ऑफ द आई लेंस, द इंक्रीज इन द फोकल लेंथ ऑफ द आई लेंस। अब यहाँ पे आई लेंस की फोकल लेंथ भी क्या हो गई है, इंक्रीज हो गई है, ठीक है। यानी कि ऑब्जेक्ट ये है, ठीक है, जहाँ पे कन्वर्ज हो रही है वो डिस्टेंस भी क्या हो गया है, इंक्रीज हो गया, ठीक है। अब दीज आर द कॉजेस। अब है नाउ नेक्स्ट इज फोकल लेंथ एंड पावर ऑफ अ कन्वेक्स लेंस यूज टू करेक्ट लॉन्ग साइटेडनेस। अब अगर आप अपने डायग्राम देखोगे, you know that long sightedness, if an object to be seen by long sighted eye is O, which is 25 centimeter from eye lens, so the convex lens used in spectacles form the image of this object at O dash. So अब ध्यान से देखेंगे what is happening, इस सिचुएशन में डायग्राम निकालेंगे फिर से। अब दिस इज द सिचुएशन। अब ऑब्जेक्ट आपके पास सपोज करो 25 सेंटीमीटर है की दूरी पे है, एन ऑब्जेक्ट हु अ पर्सन हु इज सफरिंग फ्रॉम हाइपरमेट्रोपिया, उसको कोई चीज़ देखनी है, उसका जो डिस्टेंस है आई से उस ऑब्जेक्ट का, दैट इज एट अ डिस्टेंस ऑफ 25 सेंटीमीटर। इसका मतलब है जो यू है दैट इज ऑब्जेक्ट और आई लेंस का डिस्टेंस यू होता है, दैट इज 25 सेंटीमीटर। एंड व्हेन यू आर गोइंग टू अप्लाई साइन कन्वेंशंस, then u comes out to be negative. Now after that, when you have put a convex lens, then by using convex lens, the image distance from the lens is this is object, actually this is the image from the eye lens, ठीक है। तो वो कितना है, d, v is equal to d। तो when you are going to apply sign conventions, v comes out to be minus d, yes or no, and you have to find out the focal length. So for such situations I am going to write, if you are suffering from hypermetropia, then लिस्ट डिस्टेंस ऑफ विजन में प्रॉब्लम आ रही है, नज़दीक का देखने में प्रॉब्लम आ रही है। इसका मतलब है कि इफ़ यू आर गोइंग टू पुट एन ऑब्जेक्ट फॉर सिंपलेस्ट वे, लिस्ट डिस्टेंस ऑफ विजन ले रही हूँ मैं, ठीक है, इट कैन बी एनीथिंग, ठीक है। अब इफ object is put at and u is at a distance of 25 centimeter, so it is towards left hand side and lens is here, then u according to sign conventions it becomes negative, and v image distance from the lens is equal to minus d, वो आपने डायग्राम में लिया है, ठीक है। v इमेज और लेंस के बीच का डिस्टेंस इज d, क्लियर। सो according to lens formula, 1 by f is equal to minus 1 by u plus 1 by v. Put the values, 1 by f minus 1 by u, it means minus 25 plus 1 by v, that is minus d. So it comes out to be 1 by 25 minus 1 by d, ठीक है। सो 1 by f is equal to 1/25 minus 1 by D. Clear? Clear? So power will be, this value you can find out, this can be given something in numerical, so power will be 1 by F in meters में होना चाहिए, and if it is in centimeter then 100 by F in centimeters. Clear? Let's do one. Now question is, the near point of a hypermetropic person is 75 centimeter. यानी कि the person can see till only 75 centimeter. If object is placed at a distance of 25 centimeter, he is not able to see. So आपने उस 25 centimeter को increase करके क्या करना है, 75 centimeter. Calculate the focal length and power of a convex lens. So आपके पास F will be here is, this will be V, as you can see from the diagram. Near point, this is the near point, so this near point is given as 75 centimeter. So according to this formula, 1 by F is equal to 1 by 25 minus 1 by D. So 1 by 25 minus 75. ठीक है, ये अब एलसीएम लेंगे, 25 एंड 75 का एलसीएम क्या आएगा, यू कैन टेक, मैं आपको पूरा करके दिखा देती हूँ, एलसीएम भी लेके दिखा देती हूँ. वैसे 25 एंड 75, 5 5 सा, वैसे तो 3 से करते हैं पहले, 25 ही आएगा, 25 3 सा 75, now 5 5 5 5 25, 25 3 is 75. So LCM is 75. 75 divided by 25, 3 minus 1. So 2 by 75. This is 1 by F. So F comes out to be 75 divided by 2, that is 37.5 centimeter. So 1 by F is power. So this is in centimeter, तो आपको मीटर में कन्वर्ट करने के लिए 100 डिवाइडेड बाय 37.5. सो पॉजिटिव में आ रही है वैल्यू, तो पावर विल बी 2.67 diopter. That's all for today. Now tomorrow we will going to discuss presbyopia, cataract, and going to give an introduction on the next topic, that is your prism. Yes, that is your prism, and I want you to solve question on page number 190. 4 questions are there. Please kindly solve that. Thank you.